Okay, so this is the carburetor system. As you can see, there is first a chamber, there is the fuel inlet, some valves here, but the main part is that butterfly valve and the venturi. Okay, so the fuel is gonna be taken from the tank and it's gonna be sent to the fuel inlet inside this chamber. As you can see, inside the chamber there is a floater. So once the fuel is sucked in inside the venturi, the amount of fuel inside the chamber will reduce, which will make the pivot to go up and let more fuel to flow in. Once that some amount of fuel is reached again, the floater will close the the opening for the fuel. Okay, so how it works? It works because there is this venturi and there is this butterfly valve. When you move the throttle, it's like you're moving the butterfly valve as well. If you open the throttle, you're gonna open the butterfly valve, which will allow more air to flow inside the venturi. So because more air flows inside the venturi, because of this restriction here, the air will flow faster at the restriction. As the air flow faster, the pressure will decrease. So there will be a low pressure area around this nozzle. And as you know, things tends to go from high pressure to low pressure. So the fuel inside the chamber is gonna be sucked in inside the venturi. It's gonna be mixed with the air and it's gonna be sent to the cylinder. Okay, so there is this fuel line as well. I don't remember the name, just check the name. It's gonna help us, it's gonna help the engine not to stop when we put the throttle at idle, because when we put the throttle at the idle, the butterfly valve is gonna close, so there will be a restriction here. It's gonna be like this. Then air will still flow here, but small amount, but because of the restriction there will be a small low pressure area here. So the fuel inside that line is gonna be sucked and still be mixed with the air, and it's gonna be sent to the engine, still to the cylinder. So that's why the engine doesn't stop when you put it idle, when you put the throttle at idle. So that's basically the carburetor. It just consists, so the summary, it just consists of a venturi. When the air flows inside the venturi, because of the restriction, because of the shape of the venturi, the air will flow faster where there is a restriction, creating a low pressure area. The fuel wants to go from high pressure area to low pressure area, so the fuel will be sucked in inside the venturi. It's gonna be mixed with the air, and that air and fuel mixture will be sent to the cylinder. That fuel and air mixture then thereafter will be burned and be used for the stroke stuff inside the cylinder. Yeah, that's all. So the problem of carburetor now, it might get carbicing because of the low pressure area. If there is moisture, as we know, if the air flow faster, the pressure will decrease and the temperature will decrease as well. So if the air is not the air, but if there is moisture entering inside because of the low temperature, there will be condensation, so ice will form inside the carburetor, and it's gonna block that flow of fuel and air mixture. So to get rid of carbicing, we can use the carbide, which will take the hot air around the exhaust pipe. The hot air will be directed directly inside the carburetor, and then the ice at the side of the carburetor is gonna melt, and then the flow will continue again. So he might ask you, huh? He might. I'm saying he might, but not sure. Like, why does the Cherokee don't usually get carbicin? So our Cherokee they don't get carbicin because our carburetor is situated just next to the engine. So the engine is always hot. So if ever there is ice inside, it will melt like automatically. So that's all.